So let's do a little more work here using our product property, our quotient property, and our power property. All right. Again, we can use those properties. Make sure you have them out in front of you. We can use those to go in two different directions. We can use them to expand an expression, and that's what we're trying to do here, right? Use the properties to expand the expression so that we have multiple logs, or you can use the properties to condense logarithms into a single quantity. All right, so we're going to do both here in this video. First off, let's start off talking about expanding logarithmic expressions. Use the properties of logarithms to expand this expression as a sum, difference, and or constant multiple of logarithms. Notice that we are starting off with a single logarithm, and we want to expand that into multiple logarithms. Well, here I have three different quantities inside of my log, and each one is connected by multiplication. This is 4 times x squared times y. Because each one of these are connected by multiplication, we can use the product property to rewrite this as the sum of three separate logarithms. This is log 4 plus log x squared plus log y. Now, we can continue to expand this log x squared. All right, notice that we have an exponent inside of the log. All right, we can use the power property to take that power and bring it to the front as a constant multiple. This gives us our final answer, log of 4 plus 2 log x plus log y. Notice that we have expanded the expression as a sum, that means addition of multiple logs, and or constant multiple of logarithms. 2 log x is a constant multiple of a logarithm. Let's try another one here. Here we have the natural log of 6 over the square root of x squared plus 1. Well, one thing we recognize here is that we have a quotient inside of our log. And because we have a quotient inside of the log, we can use the quotient property to rewrite that as the difference of two separate logarithms. That's the natural log of 6 minus the natural log of the square root of x squared plus 1. Again, we want to get in the habit. Anytime we see radicals, rewrite those as powers. In other words, this is the same thing as ln 6 minus the natural log of the quantity x squared plus 1 raised to the 1/2. Well, writing that square root as a power now allows us to use the power rule. The power rule says we can take an exponent inside of a log and bring it to the front as a constant multiple. That gives us our final answer of the natural log of 6 minus 1/2 the natural log of the quantity x squared plus 1. Make sure you are paying attention with your parentheses. We are taking the natural log of this entire quantity x squared plus 1. All right, so we need parentheses around that to group those two terms together. Same thing here. Use the properties of logarithms to expand the expression. All right, we've got a square root. Well, what do square roots mean? They are the exact same thing as fractional exponents. This is the natural log of the quantity x squared times x plus 1, all raised to the 1/2 power. Now, we have multiplication going on here, but we can't use the product rule just yet. We have to start off with the power rule because this exponent belongs to every single term inside of the log. Well, the power rule says I can take that exponent and bring it to the front as a constant multiple. That leaves me with 1/2 times the natural log of the quantity x squared times x plus 1. Now, I have these two groupings inside of my natural log, and they are connected by multiplication. I can expand those by rewriting that as a sum of two different logs. This becomes 1/2 times, and notice I put big brackets around here, right? Because it's 1/2 times this entire quantity of the logarithm that we're breaking up. So 1/2 times bracket natural log of x squared plus the natural log of x plus 1. Couple last steps here. Notice again, we have a power associated with a quantity in a log. We can bring that to the front as a constant multiple, giving us 1/2 times 2 ln x plus ln of x plus 1. And finally, we can use the distributive property of multiplication to multiply each term here by 1/2, giving us the natural log of x plus 1/2 times the natural log of x plus 1. Again, that x plus 1 in parentheses. Okay, so don't forget, your basic rules of algebra still apply. I can still use the distributive property of multiplication and multiply each one of these logs by 1/2. All right, one more final expansion problem. We have log base 3 of 9 divided by x squared y. Well, we have a quotient going on here, and that means I can rewrite my quotient as the difference of two logs. This would be log base 3 of 9 minus log base 3 of x squared times y. All right, let's begin to simplify here. Now, log base 3 of 9, we can actually reduce that quantity. This is saying 3 raised to what power gives me 9? Well, that's 2. Therefore, log base 3 of 9 is going to equal 2. Minus, and notice here, I have two values inside of my log connected by multiplication, x squared times y. So I can rewrite this log as the sum of two separate logs. This becomes 2 minus, and notice you have to put brackets around it because this is the entire quantity of log base 3 of x squared y. I'm subtracting that entire value. So we have to remember we're going to have to distribute this negative in just a second. So we have minus bracket log base 3 of x squared plus log base 3 of y. I can now use my power property here as well to bring this squared to the front as a constant multiple. We have 2 minus bracket 2 log base 3 of x plus log base 3 of y. And to get our final answer here, all we have to do is distribute our negative to each of our terms. Again, simplify. 2 minus 2 log base 3 of x minus log base 3 of y is our final answer. All right, so there you have it, using the properties of logarithms to expand a single logarithm into multiple logarithms. In the next video, we'll be doing the reverse of this, taking multiple logarithms and condensing them into a single logarithm.